The stewardess said both pilots.
Can you fly this plane and land it?
Surely you can't be serious.
I am serious. And don't call me Shirley.
After I posted my original video on how I fly the Concorde, I had a tremendous response, a tremendous positive response from viewers, and a lot of requests for a video on how to operate the fuel panel. So I have put together this video that goes through how the fuel panel is to be properly operated in a normal flight, plus some special situations and also some scenarios where things go wrong and how to fix it. So I'm really hoping that after you watch this video, you'll be very comfortable turning off the VFE, the virtual flight engineer, and operating the entire fuel panel and hopefully the pressurization panel. And I think there's one other thing the VFE does, and operate that all by yourself and do the complete flight from cold and dark all the way to shutdown at the other end of the flight. So good luck. If there are any questions you have, please post them on my YouTube channel, and I will do my very best to answer all of them. Before we go ahead and get stuck into the details of the fuel system on Concorde, I thought it'd be a good idea just to review a definition of the center of gravity. We talk about it so much when you talk about Concorde fuel that it's a good idea just to get this out of the way up front so we all are operating from the same definition. So this is a definition I found, which I thought was actually pretty good. The center of gravity, CG, of an aircraft is the point at which the aircraft would balance if it were possible to suspend it at that point. So I think we all understand what that means. And I think everyone can understand that depending on where the center of gravity is in an aircraft, it will have a significant impact on the angle of attack, the amount of input from control surfaces that's required to fly the aircraft, and its performance at various speeds and altitudes. So whether it's on the ground or in the air, the center of gravity is extremely important on any aircraft. On Concorde, it's even more important because of the extreme range that we're going to be adjusting center of gravity throughout the various parts of our flight. So just wanted to start with that, and now we will move on to the specifics of the Concorde fuel system. What we're looking at here is a schematic of the Concorde fuel tanks on the left and the fuel panel on the right. What I'm hoping to do over the next few minutes is to break down the fuel panel piece by piece so you understand each of the components. And then after this is all done, we will go through an actual flight where I just show the workings of the fuel panel throughout the entire flight. And hopefully at the end of that, you'll be quite comfortable in how the fuel panel needs to operate for Concorde. So the first thing to do is to take a look at our fuel tanks that actually feed the engines. So these are the engine feed tanks. They're also known sometimes as the collector tanks. And tanks 1, 2, 3, and 4 feed engines 1, 2, 3, and 4, which is very common in every aircraft. Every aircraft has a fuel tank that's feeding an engine. The really important thing to note here is that the physical location of some of the tanks is different to what is shown on the fuel panel. For the most part, the Concorde panel falls within the layout of how the tanks really are in the plane, but there are a few exceptions, and you need to really understand those to understand how the fuel works on this particular aircraft. So tanks 2 and tanks 3 and collector and engine feed tank 2 and 3 on on the panel and the schematic are in the same location at the back of the plane. Tanks 1 and 4 are physically located further to the front of the aircraft, but on the panel they're located at the back. So that's really important to understand. Tanks 1 and 4 are physically located further to the front of the aircraft than they are shown on the panel, and that'll become really important as we go through this. The next slide here, or the next diagram, is showing the main transfer tank. These are the main fuel tanks where fuel is stored. The Concorde obviously has a tremendous amount of fuel on board for a normal flight. Just to put it in perspective, for a New York to London flight, you've got something in the neighborhood of 90,000 kilos of fuel. So what's that, 200 and something thousand pounds? That'll keep a 747 fully loaded in the air for 10 hours. So I mean, it's a lot of fuel on board the aircraft. So you've got the main tanks in the center, and again, there's a little bit of a quirk between where the tanks are physically located in the aircraft versus where they're shown on the panel. So tanks 5 and 6 are correctly shown, 5 in front of 6. 5 is in the front, 6 is in the rear of the aircraft, but 7 and 8 are switched. 7 is in the front on the panel, and 8 is in the rear on the panel, but in the aircraft, 8 is actually in front of 7. So another little area to make note of. The next slide shows two important tanks. They're called the wing tip tanks. They were used for trim and also as main fuel tanks. These were kind of unique tanks in that they had to be full for the takeoff, but they had to be empty for the landing, and that had to do with the shape of the delta wing and optimizing the aerodynamics. The important thing to keep in mind with regard to these tanks is that the location of the tanks is in the wing tips, but on the fuel panel you'll see that these tanks are located quite far forward. So just keep that in mind, that they're actually at the back of the plane, not at the front, when you're working with these wing tip tanks. We'll talk more about this a little later when we get into setting up the aft trim for the aircraft. Next, we get to kind of the unique and distinguishing feature of the Concorde fuel system, and that's the trim transfer tanks. There's tank 9 at the very front of the aircraft, tank 10 right behind it, and tank 11 way at the back of the aircraft behind the delta wing. And these tanks are used to move the center of gravity of the aircraft back and forward throughout the flight envelope. And they are fortunately located properly on the panel in terms of their location on the panel is the same as where they are on the actual aircraft. So if you take a look at this diagram, you'll see that on the vertical axis, we have center of gravity of the aircraft, CG, where the larger number is aft. So a CG of 60 is aft, whereas CG of 51 is forward. And we have speed on the horizontal axis, 0 stationary up to Mach 2.5, which this Concorde never went, but that's the graph. And you'll notice something very interesting. As the speed of the Concorde increases, the center of gravity has to move backwards in the aircraft in order for the aircraft to remain in the normal flight envelope. It cannot move outside of those green lines that you see. So on a normal aircraft, a 747, 777, 67, Airbus, the center of gravity stays relatively the same over the flight. It doesn't need to be moved all over the place. And the tanks are designed to accommodate whatever little movement is required or is needed for the flight. But on Concorde, the center of gravity has to move so much that you have to actually move fuel around in order to move it backwards and forwards throughout the flight envelope. So that's accomplished with these trim transfer tanks, where fuel is transferred backwards to tank 11 on the climb and forwards on the descent. And we'll talk a lot more about that throughout the course of this video. And now that we're completed discussing the or finished discussing the tanks themselves, I'll just go from top to bottom over other parts of the panel that are important to know about. On the top left of the panel is the equipment bay cooling. You don't touch this very much during the flight, just at the beginning when you apply power, when you turn on the cooling. The reason is if you don't, the panel will overheat and all of the power will shut off. So that's one step you have to take at the very beginning of the flight, and then you leave it until the end. The top right is the jettison panel, which normally on an aircraft, a normal aircraft, you see the jettison panel and you may know how to work it or know what it does. But the reality is the only time you ever use it is to jettison fuel overboard. You never use it for any other purpose. On Concorde, the jettison panel is used for the purpose of jettisoning fuel overboard. But more importantly, the pumps in the jettison panel, pumps 1, 2, 3, and 4, are used to pump fuel around the aircraft. So that'll come into play later on. Moving down the panel, we have the standby inlets, and these are inlet valves to various various fuel tanks. So in order to move fuel around, you need a way to get the fuel into the tank, an inlet, and you need to have a method of moving the fuel, a pump. So the jettison pumps and the inlets are used quite a bit to move fuel around the aircraft. At the bottom, below the gauges for the fuel amounts in the 4 collector tanks are the actual main feed pumps. There's actually 3 pumps, a main pump and 2 auxiliary pumps. And below that is the jettison and crossfeed system, which at this bottom panel, it's rarely used, but it's important to know about. And the last, most important thing on Concorde in terms of the fuel panel is the center section, which is the trim transfer control panel. So this is the part of the panel you use to move fuel forward and back, and it shows you the gauges, so you know exactly what you're doing and what your center of gravity is and what the limits are. These little bugs here, what the limits are as you're moving fuel around the panel. And finally, I just want to talk a little bit about the wing tanks, the special wing tanks that have to be emptied in cruise, because they have to be completely empty when the aircraft lands. There's a little button here, or a little switch here on the fuel transfer section of the panel where it says aft trim. And at a specific point in the flight, we're going to switch that to aft trim. And what's going to happen is fuel is going to empty out of tanks 5A and 7A. But remember, the location of tanks 5A and 7A on the panel is different to the aircraft. In the aircraft, they're located at the back and in the wings. And if you empty these 2 tanks, the center of gravity of the aircraft will move forward. So in order to counteract that, because by the time we get to the point where we want to empty these tanks, we've already set up our center of gravity for Mach 2 cruise climb. We do not want it to move forward. At the same time these tanks are emptied, we also empty tanks 1 and 4. We don't empty them completely. We just move the fuel down by kind of half of where it starts out. But it counteracts the action of emptying the wing tanks, 5A and 7A, and it keeps your center of gravity stable as these wing tip tanks are emptied. And last but not least, before we get into setting up our actual flight, and I walk you through that whole part of the video, in the Concorde documentation, I believe it's in the fuel section, there is a chart which shows you what actions you have to take to move fuel from any one tank to any other tank. You have to have this chart available print it out, have it on a PDF on another computer, whatever you've got to do, you have to have this chart available, because the last thing you want to do is be in the middle of a flight and have a situation that you have to address by moving fuel from a particular tank to another tank, and you don't know how to do it. So I would highly recommend that you have this chart available. After you've done this a while, you can figure it out without the chart, but I would not recommend that right off the bat. Okay, well, whenever you have a complex process, you want to break it down and develop a methodology, a strategy, a process of working. And we're going to do that right now with the fuel panel. We're going to have what I'm calling a fuel management strategy, but I guess that's my own wacky name for it. There's no official name, but this is what I'm calling it. So this will take you through step by step what is going to happen on our flight. So step one, we are going to set up our panel, set all the buttons and switches and everything in the right place for our flight, and we're going to set the takeoff fuel for tank 11. So the center of gravity has to be set for takeoff, and it's done by moving fuel into tank 11 and setting the takeoff value. So that's step one. The next step is we're going to have to move fuel back once we hit a speed of Mach 0.7, which is actually great news, because that means from the time you set your takeoff CG, or takeoff fuel in tank 11, to the time you're well on your way, you've got your automatics going, your INS is all controlling the plane, you're climbing probably through, well over 10,000 feet, I'm guessing. By the time you hit Mach 7, or Mach 0.7, you don't have to worry about the fuel panel until well after the takeoff. So after you're airborne and you hit Mach 7, you're going to move fuel back, and you're going to fill tank 11 to 10,500 kilos. Once tank 11 is filled to 10,500 kilos, you're going to continue to move fuel back into tanks 5 and 7, and keep filling those tanks until the center of gravity reaches 59%. Once our center of gravity reaches 59%, we will stop moving fuel out of tanks 9 and 10 and set our aft trim. The aft trim will reduce fuel in tanks 5A and 7A, the wingtip tanks, and also reduce the fuel in tanks 1 and 4 to keep our center of gravity stable. After we've initiated the emptying of the wingtip tanks, we're going to balance fuel left to right, port to starboard, or whatever, and we have to move fuel across the ship to balance the fuel and relieve pressure on the elevons. And then we're basically going to leave things the way they are for the rest of the cruise, but when we begin to decelerate and descend, we're going to move fuel forward and lower our CG. We're going to move fuel forward from tank 11 until it's empty, and fill up tanks that are in front of it. And then we're going to, at the end of our flight, we're going to shut down our panel. We're going to move fuel to the front of the aircraft so it doesn't tip back when it's on the ground, and we're going to shut down our panel. So that's kind of the strategy we will follow for the flight. And it kind of gives you an overall summary of what we're going to accomplish as we move through our Concorde flight. We've loaded our Concorde at London Heathrow Gate 421, and just want to go through the proper way to do this. You want to first of all use your Flight Sim Labs options and load a panel state of cold and dark first, and then after that you want to go into the options for aircraft fuel and aircraft load. Today we're going to be using the default load, so we'll apply that. And for our fuel, we're going to just pick London to New York. It'll set up the fuel for us. We're going to go back to the aircraft load and write down these numbers because we're going to need them for the flight. And then we're all set. What you do not want to do is go into the default Flight Simulator X menu for fuel and payload and make adjustments there. That will completely mess up everything because Flight Sim Labs does not use the default system. It has its own external way of handling fuel and payload. So you must go through the Flight Sim Labs menus when you make these settings. I'll just mention briefly that there's one other method of getting fuel into the aircraft, and that's using the program Concorde Performance System. It's a very sophisticated program that allows you to customize many aspects of the flight, particularly allows you to work out all the proper numbers for any route. So any route that you're interested in, even if Concorde never flew it, you'll be able to get the proper fuel numbers, engine numbers, all that kind of stuff. So you can check out Concorde Performance System. It's a great program and highly recommended, and something you can use if you don't want to use the default Flight Sim Labs method of getting the fuel and payload into your aircraft. Okay, so we're at the gate, cold and dark. We've requested our ground power and air, and I'm just about to flip the switch to get some power to the panel. And as soon as I do that, I will need to turn on the equipment bay cooling, which I'm flipping on now, and that will ensure that there's enough cooling so that the panel will not shut down. Okay, so here's our fuel panel. Everything is shut down, although we do have power to the fuel panel itself, and it's time to set up the fuel panel for our flight. So the first thing we need to do is to check the zero fuel weight, and I've written it down from the load sheet that we originally used, and that original zero fuel weight is 88.4, which is set correctly here. The zero fuel CG is 52.5, which is set correctly. Now we have to put in our zero fuel weight down here in our aircraft weight. So we're going to rotate this. It's 88.4. And as usual, I always get this wrong. But okay, so here we go. 88, 1, 2, 3, 4. This goes to 0. Okay, and now we're going to set our fuel. I right-click here to zero it out, and now we're going to add our fuel, which is 92,033. And put it on normal, and our total weight, which we wrote down, is 180433, 180430 in the end. That's fine. So this is exactly correct. So now we're going to go through our fuel panel itself and just make sure all of our switches are where they should be. So here we have our tank 9 inlets and overrides. The main pumps need to be on auto and the overrides need to be on off. The pumps on tank 9 need to be on. Actually, they need to be on auto, not on. The D-air remains off for now. The tank 10 pumps need to be on auto. The pumps for 5A and 7A stay closed. All of the standby inlets for each of the tanks stay closed. The jettison panel is default. Everything's closed and closed up. The trim pipe inlet is closed. And there's 3 of those, one here, and one here for tank 7. So that's going to stay closed. The tank pump for tank 5 is closed. For tank 7, it remains closed. The main inlet will leave shut because when we transfer our fuel from 9 down to 11 after start, we want that to be closed, which you can just leave it closed for now. The override should be on off, so we put that on off. The interconnect valve between tank 6 and 7 is shut. The interconnect valve between tank 5 and 8 is shut. And tank 6 and 8 pumps, 6 pump 1 and pump 2, and these 2 pumps for tank 8 remain closed. Alright, so now we're moving down to tank 11 setup. Again, the mains need to be on auto and the overrides need to be on off. The hydraulic pumps, there's one for each system. The yellow system and green system should be on auto. And the pumps should be on auto, but the D-air remains closed. And then our engine feed pumps, there are 3 pumps for each engine. There's a main pump and 2 auxiliary pumps. We need to turn the main pump on tank 1 on, the main pump on tank 2. We leave, just trying to get the pop-up to show, but it's not. So the main pump is on tanks 3 and tank 4. So now our panel is completely set up correctly for our engine start, and once we start up the engines, we'll proceed item by item onto the next part of our panel. One last thing over here, the main trim transfer. Our trim transfer should be closed and guarded, and our aft trim should be on normal. And you can see here the MI, the mode indicator, is normal. Alright, so we're at the part of the taxi checklist where we need to set our fuel panel up as part of our taxi. First thing we need to do is to move fuel back into tank 11 so that we set our takeoff CG at 53.5. If you're using the Concorde performance system, it'll actually give you a value to put into your load limit controller. I'm thinking that today the limit is going to be something like 7,000, maybe a little less, but we'll just throw it up to 7,000 for now, and we'll move our fuel back. I'm just going to watch it closely and go through this step by step. So let's slow down here. We're going to unguard it and then move it back, and now you're going to see that fuel is starting to come out of tank 9 and it's going to go into tank 11. Now, because we've had the inlets for tank 5 and tank 7 closed, no fuel is going to go into those tanks, so that's why we closed that. So now this fuel is going to come back, and you can see this is slowly going up, and I think 7,000 is not going to be quite enough, so I'm going to add some more here. Probably 8,000 is where it'll end up. So we'll just watch that. While that's going, I'll just go through one more thing. We need to arm our low pressure protection, our LP protection, so we're going to turn that to armed. And we're just going to wait here until our fuel goes up to 53.5, which it's at now. So I miscalculated the limit. It's 53.5 now, so I'll just close that, and I'm trying to guard this thing, but it doesn't seem to cooperate. Okay, there you go. So now it's guarded, and we can actually now move to the next step, which is we need to move our load limit controller up to 10,500, which is our climb value, where we're going to move fuel back to 10,500, and then once that's full, the fuel will then go from tank 9 and 10 into the main tanks 7 and 5 and 7. So first thing we need to do is we need to move the inlets for 5 and 7 back to auto. The next thing we need to do is we need to turn on all of our engine feed pumps. They all need to be on. And then the last thing we need to do is we need to turn on the D-air for, well, actually it's not the last thing we have to do. We have to turn on the pumps for tank 5 and tank 7. You need to turn on both pumps because the left-hand pump feeds engine 1. The right-hand pump feeds engine 2. Same with tank 7. The left-hand pumps feeds tank 3, the right-hand tank 4. So you want to put both of those on. And then the next thing we need to do is we put all the D-air pumps. And the D-air pumps basically work the fuel and keep it from boiling in the tank. So we need to turn on the D-air for tank number 10. We turn on the D-air for tank number 11. We turn on the D-air for tank 6 and 8, which is actually just the right-hand pump. So we turn the right-hand pumps on for both of these. And then for tank 5A and 7A, we turn on both of these pumps and they act as D-air. So now our panel is completely set up for our departure, and we don't actually have to touch it again until we're at Mach 0.7. 0.7 Mach, that's when we'll begin to move the fuel backwards once again. So I will be back once we've completed our takeoff and we're in the air. We're approaching a speed of 0.7 Mach. I'll just zoom in now to show you that, so you can see that, oops, that's a little rough, sorry. So you'll see we're at 0.7 Mach now, and we're climbing, approaching a speed of 390 knots. I'll just put in my speed now, and I'll come back in a second, but at 0.7 we go through our climb checklist. I'll do the other parts right after this, but I want to get into the fuel part first. So we need to move fuel back at this point. We're going to unguard our trim master and move it backwards. You'll see fuel moving from tank 9 into tank 11. And now that fuel is moving into tank 11, we no longer need our D-air for tank 11. So I'm turning that off. And fuel will begin moving back now into tank 11 and also a little bit into tanks 5 and 7. But it'll stay between the limits the entire time. We'll stop our transfer once we reach a center of gravity of 59%. Okay, well, on our climb out or flight out of London, we have a subsonic leg, and actually we're not going to be going supersonic until we reach the waypoint upgas, waypoint number 4. So we have 65 miles subsonic. And normally what we do on a subsonic leg is we stop our rear transfer of fuel at 55. So I'm going to stop that now. Just waiting for the center of gravity to reach 55. We're leveling out at our intermediate flight level of flight level 260. And as soon as the indicator shows 55, there it is, we will turn off our transfer of fuel and just leave it there until we are ready to proceed with our supersonic acceleration. We are approaching our supersonic acceleration point, the waypoint upgas. We're 8 miles out, so we need to get ready to begin moving our fuel backwards again. So what I'm going to do is just go through the acceleration, start climbing, add our afterburners, and then I'll switch to the fuel panel and show you turning the fuel back and continue it moving backwards. So now we're unguarding our trim transfer switch and transferring the fuel back again. You'll see that the fuel is beginning to move again into tank 11, and it'll continue to do so until it's at 10,500, which we're very close to now. And then we'll continue to fill up tanks 5 and tank 7 until we reach the magic number of 59% on our center of gravity. Okay, so our tank number 11 has reached 10,500 kilos, so I'm just resetting the load limit controller, just moving it down to 0 because we're going to have to move fuel forward from this tank to keep the CG at 59%, but also on our deceleration and our descent. We're approaching a speed of Mach 1.7, and the pressure in our fuel tanks is such that we no longer need our D-air pumps. So I'm just bringing up the fuel pressure gauge. You can see it here. I'm not 100% sure that this is working right because I did not see a big change from Mach 1 to Mach 1.7. But nonetheless, we'll turn off our D-air in tank number 10. Well, I'll turn off the D-airs for tank 6 and 8. The tank 11D air is already off, but we're going to leave our pumps on for 5A and 7A because very shortly we're going to be moving that fuel from the wingtips and switching to aft trim. Our CG is now 58.8. Tank 10 is down to 1,100 kilos, and we're reaching the end of our fuel transfer. Once the fuel transfer has stopped, the CG will slowly move backwards about 0.3 over the remainder of the flight. So if you're a little lazy, you can actually stop it here and it'll move back to 59.1 or something like that. But we'll do it properly today. We're approaching the end, 58.9. Tank 10 will probably empty out almost completely by the time we stop the transfer today, based on the way our fuel is set up. So I'm just waiting for the fuel transfer to complete. And there we go, 59. So I'll stop the fuel transfer at 59.0, and tank 10 has a little bit left, 120 kilos. We'll leave that there for landing. And now what we're going to do is we're going to open up the trim pipe drain and the inlets. So we open up the trim pipe drain, we open up the inlet to tank 5, and then we open up the inlet to tank 7. And we observe that fuel from the wingtips, tank 5A and 7A, is starting to transfer into these main tanks. And we observe that that's moving, which it is now. And now we're going to click our aft trim switch. Now you recall that tanks 1 and 4 are actually located further up on the aircraft, and these wingtips are actually located further back on the wings. So what's going to happen is tanks 1 and 4 will actually start emptying out down to 2,000 kilos as tanks 5A and 7A begin to empty, and it'll keep our CG stable at 59%. Just checking in on tanks 5A and 7A, down to 1,280, 1,180. They do go down at different rates, so that's normal. And if we look at tanks 1 and 4, they are starting to drop now, and our CG is basically in balance. We stopped it at 59.0, it's now 58.9. That'll slowly move back, so everything is as it should be. We're at the point now where tank 7A has completely emptied out, and tank 5A is almost empty. So we're going to have to now shut down the pumps. I'm just going to wait until 5A completely finishes emptying out before I do that. And let's just check the amount. Yeah, we've got basically nothing left in 7A. It's just scavenging the last little bits of fuel. It always leaves a little bit in the tank. And once that's completed, then our transfer is done, and we can basically sit back and just monitor our fuel for the rest of the cruise. We are going to have to move fuel across the ship at some point to balance the left and right sides, because there's more fuel on the right at the moment, and that does have an impact on performance of the aircraft. So we're at the end of the transfer here at 5A, so I'm closing those pumps down. I'm going to close the inlets, and I'm going to close the trim pipe drain. But we leave our aft trim indicator in aft, and you'll notice that the fuel weight in tanks 1 and 4 has moved down, and it'll continue to move down to about 2,050, I think. I'm going by memory here, but it'll continue to move down, and then it'll stop for the remainder of our cruise. We're looking at the gauge now for the elevons, and you can see there's a bit of deflection below zero for some of the elevons, and we need to correct that. That's a result of a fuel imbalance, and we need to correct that and balance out the left and right side. So on the right side right now we've got 13,600 kilos. On the left side we've got 11,300 kilos. So we need to move fuel to balance it out. So we're going to open up the inlet on tank 5. We're going to turn on the pump for tank 11. We're going to open up the inlet to tank 11 and turn on the pump for tank 8. And then turn on the jettison for tank 3. So what that results is fuel being pumped from tank 8 into tank 3, into tank 11, and up into tank 5. And that will move fuel from the right side of the aircraft to the left side. And we'll continue to monitor this until our fuel is completely balanced. Okay, we've been running this for a little bit now. The fuel in tanks 5 and 6 has moved up significantly, and then in tanks 7 and 8 it has dropped significantly because we've pumped it across. And we're going to actually have to close the pumps for tank 7 because that tank is getting empty now. And we're just kind of in our head calculating the weights of the two sides, and we'll stop this very soon because the two sides are balancing out. So we're going to turn on the pump for tank 8 because tank 7 is getting close to 0. So we're making sure tank 8 can take over and feed 3 and collectors 3 and 4. I just want to point out as we turn on the right hand pump for tank number 8 that previously I had turned on the pumps for tank number 6. So as tanks 5 and 7 start to run out of fuel and head down to 0, you do need to turn on the adjacent tanks 6 and 8 so that they will continue to pump fuel into the collector tanks. Okay, so the sides are even, so we are now turning off all the pumps. We're turning off all the inlets. And now on the left side we have 11,880 kilos, and on the right side we have 11,920. So we're balanced, and everything looks really good. The next thing we have to worry about is that we notice our center of gravity is at 59.3. So we're going to have to move fuel forward now. So we're going to move fuel forward from tank 11 into tanks 5 and 7. So we're going to have to turn the pumps back on in tank 7 so that fuel can be pumped out. And then once our CG reaches 59%, we will close up the trim transfer and leave things as they are. And we'll probably be good now for probably the remainder of the flight in terms of center of gravity. And there we are at 59%, so we can close up our trim transfer. I also quickly just want to mention something about the interconnect valves between tanks 5 and 8 and tanks 6 and 7. These can be used to balance out the sides. It's not the preferred method because it's slow, so it has to be monitored a lot more closely, but it is available if you want to use that method. So just looking here again at the elevon gauge, you can see it's nicely evened out. The discrepancy we had prior to making that change of fuel is gone, and our aircraft is flying as efficiently as possible. And one last thing we need to do is we need to increase the load limit controller for tanks 9 and 10 up to 8,000 kilos. This is in the event of an emergency descent, and if the flight engineer is extremely busy, it allows the first officer to flip a switch and move fuel from tanks 11 to tank 9. In such a circumstance. So we've just moved that now to 8,000 kilos, and now we're all set. All right, so our fuel tanks 6 and tanks 8 have now reduced to 4,000 kilos a piece. They're just slightly above that now. So we're at the point where we need to move our aft trim back to normal. So obviously when you do that, what's going to happen is tanks 1 and 4 will use the fuel in tanks 6 and 8 and will fill back up probably close to 4,000 or maybe more, 4,500 kilos. And because tanks 1 and 4 are located closer to the front of the aircraft, the center of gravity, the CG, will move forward, probably around 0.5, but not enough to go past the forward bug and cause a problem for our aircraft, which is still in cruise climb. I am at this point around 300 to just over 300 miles to my calculated top of descent, but we should be fine. So I've switched the switch now back to norm, and you'll see that fuel is starting to go back into tanks 1 and 4 and fill up. And just checking in now, we can see that tank 6 is at 1,500 kilos, tanks 8 below 1,000 kilos. They're emptying out, and tanks 1 and 4 are filling up quite nicely. All right, so we're reaching the end of the fuel in tank 8. I'm just going to turn off the 2 pumps in tank 8. We have a few hundred kilos of fuel left in tank number 6, and when that gets to 0, I'll be turning off the pumps for tank 6. But I just want to have you notice the center of gravity. If you recall, when we turned our switch back to normal, the center of gravity was 59.2. It's now moved back to 58.6. So I said it would move back 0.5. It's moved back 0.6, but it's still comfortably between the 2 orange bugs, and we're set up in good shape for our deceleration and descent. And now the tank number 6 is getting to the end of its fuel, so I'm just going to turn off those pumps, and essentially we're all set now for the rest of our cruise climb. And when we get to our top of descent, we'll be moving fuel back into tanks 5 and tank 7. Just a note of caution for consistency with regard to the video. In this section of the video, I actually flipped the switch to from aft trim to normal when tanks 6 and 8 were at 2,500 kilos. Previously I did it at 4,000 kilos, so you'll notice a few different numbers in tanks 1 and 4, and also the center of gravity. But for the purposes of putting together this video, this section of video was actually much better to show what I was doing. And the actual steps are the same, so I've put this piece of video in, and I will at the very end of this section put in a comparison to show the difference of flipping the switch at 4,000 kilos, which is the proper way to do it, and the results end up being much better. Okay, so we've just begun our deceleration and descent checklist. Now we're at the part where we're moving fuel backwards, so I'm just going to move the fuel transfer, trim transfer to the forward position, and fuel will now move out of tank 11. If fuel doesn't move out of tank 11, check your selector here to make sure that you've actually moved it down to 0. And we can see fuel is now filling up tank 9, and it'll keep going until the load limit of tank 9 and 10 reaches 1,000, and then the fuel will fill into tanks 5 and 7, and that will continue for the remainder of our descent. With regard to the number for the load limit controller in tanks 9 and 10, there is a landing value that was calculated, but I do not have access to how that is done. I've arbitrarily picked 1,000 kilos. You can set it at 1,000 kilos or maybe a little bit higher, or you can just leave it at 0 and put all the fuel into tanks 5 and 7, and that'll still give you a very good result. We can see now that the load limit has reached its landing value of 1,000, and now fuel is moving into tanks 5 and 7. So I'm just going to turn on the pumps for 5 and 7, and that fuel will then pump its way into tanks 1 and 2 until those tanks are full. It's really important on the descent part of the flight to keep an eye on the center of gravity, because it can move close to that forward bug pretty quickly, and you'll want to stop the transfer and then start it up again a little later on once it's kind of more in the middle. And one final thing, if there's an intermediate altitude that you'll be leveling off at, as you do when you fly into London Heathrow, then you'll stop the CG at 55% and then start it up again on your final descent. The center of gravity has now reached the forward limit, so I've actually stopped the flow, and I'll continue on with my checklist. One last thing I need to do is turn off the hydraulic pumps for the yellow and green system. And then we've now completed our setup for the fuel panel for the descent and deceleration, and I'll start this back up once it's in the middle, and I'll check in a little later on. We've just now passed through Mach 1. We're continuing our descent, and just checking on our fuel panel, we can see that the collector tanks 1 to 4 are filling up. Fuel is pumping out of tank 11, 5,000 kilos to go, and our CG is at 56% and moving down. As we approach the end of the transfer, I'll be back to give the final numbers. Okay, so we've now finished our fuel transfer. The transfer from tank 11 is completed. The tanks are empty, so we can turn off these pumps. There's no fuel left in tanks 5 or 7, so we can turn off those pumps. And our center of gravity has ended up at 53.4. I was looking for 53.2, but that's perfectly acceptable. And we can see tanks 1 and 4 have about 3,500 kilos in them, and tanks 2 and 3 have 45. So certainly enough fuel left for our landing. We can see a total fuel of 17,000 kilos, and we're looking to land with around 15,000 kilos. So we're in decent shape. And for completeness, here are the numbers if we had moved our aft trim to normal with tanks 6 and 8 at 4,000 kilos. We end up with a CG of 53.2 and more fuel in tanks 1 and 4. So it's a better way to work, and just wanted to show you this so you had the comparison. Okay, so the final piece of the puzzle here is just a setup for our landing. I'm just going to turn off the pumps in tanks 9 and 10 because they're not needed. The pumps in tank 5, 7, 6, and 8 are off. All of our engine feed pumps are on. Our hydraulic pumps are off, and our pumps on tank 11 are turned off. Everything else is just set as per normal. So there's nothing left to do here on our panel. It's completely set up for landing, and we're basically done, except for after we land there's a little bit of work left to do. So we've just landed at John F. Kennedy. I've completed the after landing checklist, except for the part where we move fuel to the front of the aircraft, and that's just to stop it from tipping up in the air with too much weight in the back. So we're going to set the load master, it's not the load master, we're going to set the load limit to 4,000. And then what we're going to do is we're going to pump fuel from the remaining tanks into tank 9. So the way to do that is we open up our inlet on tank 9, the main inlets. Just gonna look where I'm taxing here. Then we're going to pump fuel from let's say 2 and 3 through the jettison system, and pump it into tank 9. And you can see now 2 and 3 are reducing in fuel, and tank 9 is moving up. So that'll continue as we finishing up our taxi, just make our way over to terminal 7, and I'll just keep an eye on that as we taxi in, and then all we have to do is move our fuel to the shutdown position, our fuel panel to the shutdown setup, and then we're done. It's almost done now, just a few more kilos to go, and then our transfer will be complete. And looks like US Airways has taken up our gate, so we're going to slide on into gate number 2 and complete our shutdown. Okay, we've got our 4,000 kilos in there, so we're going to turn off our jettison tanks, close it, put our mains back to auto, and we're all done. We're going to complete our shutdown and be back to put our fuel panel in the shutdown setup. Well, we're almost done now. We've parked our aircraft, engines are off, passengers are unloading, so now it's just a matter of shutting down our fuel panel. We're going to turn off all of our engine feed pumps. We're going to turn off our main and override inlet selectors for tank 9. The pumps are off, de-air's off. The standby inlets are all off. Jettison's closed up. Tank 5A and 7A pumps are closed. The trim pipe drain is closed, and the inlets to both tanks are closed. The pumps for tank 5 are closed. We'll close the inlet and the override. We'll close the inlet and the override for tank 7. We will, if I can get it to work, we will guard the transfer at neutral, close the inlet and overrides for tank 11. The hydraulics are closed and the pumps are all closed. So our panel is now completely shut down and ready for the next crew. The only thing left is to close our LP fuel protection. We don't need that because our low pressure is no longer required. If you're going to do a complete shutdown and I still have ground power, you would then turn off your equipment bay cooling, but I'm just going to leave that on for now. So that's it. We've completed our flight. So stay tuned for the next section where we'll talk about the Barbados loadout and also recovering from mistakes. Okay, so we're just beginning our taxi down to runway 09 right. I'm just going to stop it here. We've got our Barbados loadout, and that's almost a plane that's completely full of fuel. So I'm just going to stop here, and you can see that our CG is 54.2. Even with the takeoff CG switch flipped, we're still too high for takeoff. We need to move that CG forward, but there's nowhere for the fuel to go. All these other tanks are full. So what we're going to do is we're going to feed engines 2 and engine 3 from tank 11. So the first thing we need to do before we do that is we need to turn off the right-hand pumps on tanks 5 and 6. Remember, these feed engine 2. We'll turn the left-hand pumps off for tanks 7 and 8 because they feed tank 3. We're going to open the inlets to tank 2 and 3. We need to have a way of getting fuel into them, so we open up the inlets for 2 and 3. And then we open up the pumps for tank 11. And now fuel is now starting to move out of tank 11 and feeding tank 2 and 3, and the CG will slowly move forward. So I'm just going to continue my taxi now, and we'll keep an eye on that center of gravity as I continue my taxi. And it was actually quite normal for Concorde to taxi doing this process, or sometimes if it was at a short had a short taxi to runway 27 left, it would actually sit there at the end of the end of the taxiway, holding short of the runway, waiting for that fuel to be used up and the CG to move forward. So you can see now it's gone to 54.1, and we're very close now to achieving our required takeoff center of gravity of 54.0. Fuel slowly moving out of tank 11. You can see it was at 9,000, now it's at 8980. Feeding engines 2 and 3, and pretty soon we'll be at our required takeoff center of gravity. Well, we've almost made it all the way to the end of our taxiway, our taxi route to the holding point of runway 09 right. I'm just going to slow down here before we get to the runway. Take a look at our fuel. Let me see, we've actually achieved now 54%. So now we can stop the process. We will close the inlets. We'll close the pumps. And now we'll turn on our normal pumps, the right-hand pumps on tank 5 and tank 6 for de-air, and the left-hand pump on tank 7. The left-hand on 8 is off anyway. And we can see that we've achieved 54%. And we're all set now, ready for our departure with the correct takeoff center of gravity. Okay, so here's another scenario. You're taxiing along, and you've previously started your fuel transfer. Your fuel is moving backwards. You're taxiing along. You've actually set your load limit controller up to 10,500. You're going to pay attention to it, but you get distracted by talking to air traffic control or some other thing. And before you know it, your load limit controller has gone way past where you want it to go, and all of a sudden the CG light comes on and the bell starts to go. So now you've got a problem that you've got to fix before your takeoff. So I'm just waiting here for that scenario to happen, and boom, there you go. So we've got our CG. You recognize what's happened. You know, you put on the brakes. You go, oh, geez, great. I'm now at 53.9. I'm supposed to be at 53.5. So what do you do? Well, fairly straightforward to fix. You've got to close your main inlets so fuel doesn't go into tanks 5 and 7. You're going to have to, I mean, it's a bit of a pain, but you know, you're going to have to fix it. So you lower your load limit controller below where the fuel level is now. So I'll just put it down to, say, 5,000. And then you increase your load limit controller in the top to be higher than what's already there. And you're going to move fuel back from 11 all the way back into 9 and 10. Obviously nothing's moving yet because it's not high enough. I need to be at 20,000 almost. So we're just going to zoom that up, and we're getting there now. This is obviously a huge pain, but you know, you want to know how to fix it. This is how you fix it. So then all of a sudden your load limit controller is high enough, and you can see fuel's now moving back into tank 9, and this CG will start to come down. Probably a good idea to just stop here until you got this sorted before you continue to taxi. All right, so we've let the fuel go back. We're now back to 53.5, so we can turn off our trim transfer and close that up. We can turn our inlets, actually we can leave those shut, and then we just have to reconfigure our load limit controllers back to the original value. This one will go to 0, and this one to 10,500. Okay, so you're flying along, everything's going well, your fuel's all organized, and you've got some time, so you leave the flight deck for a cup of coffee, watch some TV, do whatever you've got to do around the house, and you return half an hour later or more, maybe an hour later, and all of a sudden you realize, something seems odd. I've got this fuel light on, I'm losing altitude, what's happening? So you do some investigation, and it turns out that you have forgotten to turn on the tanks for tanks 6 and 8, which means the engines are running off whatever fuel's in the collector tanks, and engine 1 is almost out, and engine 4 has actually gone out. Now it hasn't in this case, but we're going to wait for it to starve out, which will happen any second, and then I'll show you how to do the relight on the engine. So yeah, this panel's not set up 100% right because I've just come back from, I've just started it midair. But anyway, you're seeing the low pressure light, and all of a sudden you're down to 20, and you can see here very soon that engine's going to completely starve out and stop running, and there it goes. So let's just wait for that to completely lose power. Okay, so the first thing you think is, well, I know what I'll do. I'll just go to the relight panel and I will flick the relight switch and everything will be good. But that's not going to work, and there's a procedure you have to follow in order to get your engine lit again. And I might as well show it to you because this has happened to me twice on various flights, and you're scrambling when it does. So first thing is you have to obviously put the fuel pumps on so the fuel can begin pumping to these engines. The second step is you have to remove the throttle on the affected engine to idle. Step 3 is you need to go onto the overhead panel and turn off the auto ignition, just so it doesn't interfere. Oops. And then you want to turn off your HP valve. By the way, just notice that the aircraft handles actually quite nicely on 3 engines, as you would expect. It can comfortably fly on 3 engines. It's going to lose altitude and speed, but you can comfortably fly on 3 engines. Okay, so after 20 seconds has gone by, you're now in a position to do the relight. So you're going to flip your relight switch to relight. You'll see that the start valve opens, and you can turn on your HP valve, and we should see the engine starting to light up. Now you'll see it hasn't gone yet, but N2 is rising, and pretty soon it should start to light. And there it goes. And now we can turn our relight to off, and the engine will continue to increase. And stopping at around 64, because remember the throttle is at idle. And now we can apply our throttle forward, and that engine should begin to move up, and there it goes. So we're back in business. So I thought I would just show you how I do that, because I have had this problem in the past. Alright, the next scenario, and this is a fictitious scenario that I've just set up, so don't worry too much about the instrumentation, but the next scenario is we're descending, and we can't really go any lower because our CG's at the very back, at the aft limit. If you look here, the light's on, it's at the back limit, and our tank 11 is empty. And the issue, just ignore this number, it's not correct, but the issue is we've got 41,000 kilos of fuel, and we're approaching, so we've messed up our fuel. The only way out of this is we need to pump fuel into tank 9, but more importantly, I think we're a little heavy, so we're going to have to dump fuel overboard. So this is just how to operate the jettison system. So you're going to open up both of these. You're going to open up the jettisons for tank 1, 2, 3, and 4. You'll open up the jettison master valves, and fuel will be jettisoned out of the nozzles at the back of the plane. So let's just check that's actually happening. There's supposed to be a graphic on that, and there you can see it. Fuel is being jettisoned out of a nozzle at the back. It's probably best to actually jettison the fuel out of the tanks that are closest to the rear of the aircraft, so that weight will be pushed forward. So if you remember, tank 6 is behind tank 5 in the aircraft schematic, and 7 is behind 8. So we'll close off 8 and we'll jettison fuel from 6 and 7. And that should help. I'll pause the video for a little bit and just see where we are in a little while. And then the other thing we can do is transfer back into tank 9, which should be, that's also an easy thing to do to fix this. But we want to get this weight down to, say, 20,000 kilos before we start turning in towards our destination in New York. Okay, so this has been going for a while now, and as I indicated, because we've been jettisoning fuel from the rear tanks, the rear main tanks, our CG has moved forward 53.8, and we're coming to the end now on tank 7, and still a bit left on tank 6. So probably what I would do here is stop the jettisons from 3 and 4 and continue from 1 and 2 for a little bit. And that's still not going to fix the problem. Probably what I would do after, maybe I'll do that now, stop the jettison completely, turn these off and close this back up. We're down to 28,000, so that's, we can live with that, is then transfer fuel from 6 up into tank 9. And we probably, I have to consult the chart on how to do that, but let me get that sorted out, and we'll see how that, if that fixes things. Okay, so after consulting the little chart, what we need to do is we need to open the inlets to tank 11, oh sorry, tank 9, and we open the jettison on tank 1 and tank 2, and that'll jettison fuel into tank number 9, which it's doing, and that'll move the CG forward a little more. And you can see here fuel is coming out of tank 6, and the CG will move forward a little more. If that doesn't work, we'll have to figure out another tank, which makes sense to move forward, and that'll probably be maybe tank 8 is the next one, because it's got more fuel than tank 5, and put that into tank 9 until we resolve this issue of the CG and push it forward. So, you know, these are the kinds of scenarios you have to figure out if you make a mistake on fuel, but you do have the chart available to show you how to move fuel around, and you should be able to figure out the most appropriate action to take in order to fix whatever fuel issues you're suffering at the time. All right, one more scenario. This is one where we've misplanned our fuel. We're 93 kilometers, or 93 miles, sorry, from New York, and we've got very low fuel. We can see tank 1 is under 1,000, tank 4 as well. We're going to have to transfer fuel from 2 to 1 and 3 to 4. There's no other fuel anywhere on our panel. Luckily, our CG is okay. So you can do it by cross-feed, which can work. So you have to open up the cross-feed valves. So fuel will go from engine 2 through the cross-feed to engine 1, but you have to turn off the pump for engine 1. And that way fuel will just be used from 2, but you're going to have to keep an eye on it to make sure you don't starve out 2. And the engine is continuing to operate, so that is one method. The second method is we have to go back to our chart, and we have to pump fuel across from tank 3 to tank 4. So with all of these things, you need a pump and you need an inlet. So we'll open up the inlet to 4, and we'll open up the jettison to 3, and that should start pumping fuel across, which it's looks like it's doing now. So those are the ways you can deal with a fuel imbalance or running low on fuel and trying to move fuel around to make it to your destination. And this is another scenario that's happened to me. It usually happens on the longer flights because you're just at the very limit of what Concorde's range is. So Barbados, Toronto, those kind of flights are really taxing on your fuel. You got to really watch it. And if you're using an add-on weather program, and the winds aren't quite correct or the temperatures aren't correct, you're going to end up with imbalances, low fuel that you have to deal with on your descent. All right, so we're restarting our flight after pausing for a day, and Concorde's just setting itself up. And one thing you notice when you restart a flight is that the fuel panel is all messed up. All of the fuel numbers are blocked out. There are all these lights on. There is a way to fix it though. If you just turn this FQI test knob, it'll clear some of them. You might have to hit the cancel test button a few times. There goes the left side. Do that on the right side. Cancel test a few times. There you go. And all of a sudden you can read your fuel panel nicely. Now it always comes back with a few buttons that are not quite right, like these overrides. This one is always in the right position. This one never is on my computer. So and some of these are a little off, so you kind of have to go through your panel and just make sure it's set up properly. Usually the engine feeds are on, but some of the settings are off. So just some help for you if you're going to be saving flights and coming back to them the next day, which I'm sure a lot of people do because these are long flights for some. Concorde actually does a tremendous job of saving all the settings, and your INS saves up nicely and everything. You can see here my INS was fine, but it's just a matter of getting your fuel panel organized. Sometimes the total contents on the main panel will be scratched out with a black and red bar, but that'll go away after 20 minutes or something. So anyway, I hope that'll help some of you that are breaking up these flights. Well, there you have it. That's my fuel video for the Concorde. I hope this video has been helpful and that you now have a much higher level of comfort with the fuel panel, and that you'll feel like you can easily turn off the flight engineer and do all the operations yourself. If you have any questions, please post on my YouTube channel. I'll do my very best to answer them. And I wish you all the best flying the Concorde.